Welcome back, polar bears and polar cubs. We're going to be talking about three columns today. We're talking about columns 9, 10, and 12. So let's focus on 9 and 10 right now. Uh, Column 9 is a sigma bond. A sigma bond is the first bond that happens between the nuclei. Okay, it is the stronger of the bonds. It happens between an S and an S and a P, or a P and a P. They are end to end. Okay. So what happens is you might, if this was a P to a P, you might have the ends overlapping. A pi bond is the one that lies between the nuclei, but it is the second to form. It is much weaker. It is always P to P. And when these ones happen, they are side to side. So they kind of barely can touch. Overlapping, they can really hold on. So let's count some sigma bonds. So between C and C here, the first bond is a sigma. There are no other bonds, so we have 0 pi bonds. Between the two C's here, we have 1 sigma, and then there is 1 left over, and that means we have 1 pi. Here we have 1 sigma, and then there are 2 left over, making it 2 pi. Now, something that I want to remind you, when it comes to sigma and pi bonds, these get aka dashes if ionic. So we will still count pi and sigma bonds, or sigma bonds and pi bonds, if it is only two atoms bonded together. When it comes to resonance, so what does resonance really tell us? Well, in order to have resonance, you must be able to draw a molecule in more than one fashion. So they have to have at least a double bond or a triple bond. They have to have 3 or more atoms. And we're going to rearrange them, but we're not going to move the central atom. So a great example of this, okay, we'll use PO2 minus really quick. So with PO2 minus, that's one way you could draw it. However, someone else could draw it this way. And they would both be correct. So how do you tell me that it has resonance? Well, you're going to put a capital Y, which is yes, and then you're going to put a dash and tell me how many different drawings you could possibly have total. So with this one, you can have 2 drawings. Let's try another one. NO3 minus. So on this one, you have 6 plus 18, giving you 24. Okay. So with 24, you're going to have N in the middle, attached to each O. Now I know right now, if I gave everybody 8, this would be 8, 16, 24, I wouldn't be able to put the 2 extra on nitrogen like I need to. So I'm going to have to put a double bond. So I chose that one more so for convenience than anything else. So I put a minus. Now, this one could also be drawn with the double bond going down. It could also be drawn with the double bond going to the left. Which one's right? They all are. Resonance kind of tells us, like, hey, you know what? Because of the double bond or the triple bond, there's more than one right answer. So for this, what you would type in for the answer would be Y-3, because there are 3 possible drawings due to the resonance of that molecule. Now, let me step back 1 second and tell you really what resonance is. What resonance is the fact that all of these drawings are taking a snapshot of the molecule in time. So at some point, this double bond can move to this one, and then it can move to this one, and then actually moves back. So what actually happens is this double bond never actually stays between one N or the N and one of the O's. It's constantly traveling amongst all three of them, or between all three of them, in order to kind of hold them a little bit tighter. So it kind of rotates around, and this is called resonance. By being resonant, when having resonance, that double bond fluctuates between the different atoms. All right, that is it for the day. When we come back, we'll talk about molecular polarity.